The last shape we're going to talk about is the polygon and the polyline. They're similar, they're related. One is a closed figure and the other is an open figure. So a polygon class defines a polygon that simply connects a sequence of points together. And the reason it's a closed figure is the last point is connected back to the first point. So in diagram A on the left-hand side, a total of 5 points have been defined: x00, x11, x22, x33, and x44. What will happen when you use those points to define a polygon is a line will be used to connect point 0 to point 1, point 1 to point 2, 2 to 3, 3 to 4, and finally one final line to connect point 4 back to point 0. So in other words, in the list of points you use, or the sequence of points you use to define a polygon, there's always going to be a line from the very last point in the sequence back to the first point in the sequence. The distinction then between a polygon and a polyline is that a polyline does not do that last step. It does not connect the last point to the first point. It leaves it open. Apart from that, they'd be the very same. Here we see a UML diagram for the polygon, and as you can see, the constructor consists of a variable number of points. So we have double, and then you see the ellipsis, 3 dots, and then so many points that we may wish to put in. So we could just put in 2 points or 3 points or 4 points or as many or as few as we like. At any point in time after the polygon is created, we can take a look at the points that make it up by using the getter that you see here for get points, which returns an observable list containing all of those points. And of course, the UML diagram is by no means complete. It's been condensed down just to show some of the more important things. So to wrap up chapter 14 of our text, we're going to look at one final demo for the polygon. So again, at the top we have all our imports, we have our extension of application and our overriding of stage. We have all the usual stuff to actually show the finished result of our work down here at the bottom. And once again, the authors basically crammed all the new stuff into one single thing here, where a scene is created using my polygon. So we need to look at my polygon to find out what actually happens here. Okay, and as usual, I'm going to get rid of that little bit. So let's take a look then at the rest of this code to see what happens here. You'll notice once again, as we saw in the last demo, we're extending pane when we make, in this case, polygon. Last time we did my ellipse, extended pane. Now it's a polygon that's going to extend pane. As we did with the last time you saw this technique, we had a paint method, and we also overrode the set width and set heights. And for the same reason as we talked about last time, we're doing the very same thing again, using the very same technique. So we call the existing set width from our superclass, existing set height from our superclass, but then in addition to that, we actually execute this paint method. So in other words, all the work is being done by the paint method, which is defined right up here. So the first thing you'll see that's kind of interesting here is that we can go ahead and create an empty polygon, which we've done in this line, and then even before we define any points for it, we can still define a fill color, and we can still go ahead and define a stroke color for it. So it's going to have a black outline, it's going to be filled with white. We know that even though it doesn't even have any points yet. The next thing we do is we create an empty list of points as an observable list of double, so that's going to be double numbers that represent particular points along our polygon, using the same xy coordinate system that we use throughout our discussions. Notice that we set our empty list equal to polygon.getPoints. Well, polygon is this empty polygon that we've made back here. It's got no points in it yet. So when we do a get points, we get an empty list of points. But the point is we now have, even though it's an empty list, it's compatible with our polygon at this point. So list now becomes an empty list of polygon points. The next thing we do is begin to populate that list. Now to do that, we're going to first of all figure out where the center of our polygon is going to be. And it's going to be a six-sided figure, so it's actually going to be a hexagon by the time we're finished. In any case, we start by figuring out where its center will be. We want it centered in the window. So what we can do to ensure that it's at that particular place is we can calculate center X and center Y ahead of time based on the current window size. So in other words, we declare two doubles here in this line, one called center X and the other called center Y. We give them initial values of get width, that's the width of the pane, divided by 2, and get height, that's the height of the pane, divided by 2. So that marks the center of the pane. Now because we're interested in ultimately producing a polygon which is a hexagon, we want the points on that hexagon to lie on a circle, and we want the circle to lie completely within our pane. We know the center of the pane, so we know where the center of that circle is going to be, but now we need to figure out how big to make the circle upon which those points are going to lie. We're going to pick the smaller of the width of the window and the height of the window. So we're going to do a math.min on get width and get height, and that will return the smaller of those two values. We don't want the circle's radius to be that big because then it would still it'd be too close to the edge of the pane. So what we do is we put a little factor in and we multiply that by 0.4 to make it a little bit less than half of that size. So that means that the points of the circle is going to lie nicely within the window or the pane. So what we have from these two lines of code is basically a calculation of the center of a circle and its radius such that the points of our polygon are going to lie upon that circle. Those points will be described by an angle which goes around the circle from 0 to 360 degrees. And basically we're going to divide that angle of 360 into an appropriate number of pieces to represent the appropriate number of points that we wish to represent. So you can see that our for loop here is now going to represent the 6 points of our hexagon. I will go from 0 to 1 less than 6. In other words, it'll go from 0 to 5 to represent 6 unique angles. The first angle is going to be 0 degrees, and it will simply be the value of I0 multiplied by a whole bunch of stuff here divided by 6. It's still going to be 0. So our initial angle is going to be 0, and based on trigonometry, we know that if we draw a line from the center of the circle to the radius, then the x and y values are going to depend on the cosine and sine of that angle and the radius, and we simply multiply radius by the cosine of the particular angle that we have, and we multiply radius by the sine of the particular angle, and those two results, when we add and subtract them from center x and center y, will give us the x and y coordinates as we travel around in a circle. And obviously we're dividing by 6 here because there's 6 points total. If you think about what's going to happen, then you're going to have 0/6 of a full circle, and then 1/6 of a full circle, 2/6, all the way up to 5/6 of a full circle. We don't go all the way to 6/6 because that just puts us back to a full circle, which is still 0 degrees again. Each of those angles now is expressed in radians, not degrees, because that's what the cosine function here and the sine function here expects to see. It doesn't want to see an angle in degrees, it wants to see an angle in radians. So the way we achieve that is multiply, there's 2 pi radians in a full circle, so we have the 2 here and the pi here, so there's our 2 pi, that's a full circle, and then the fraction of the circle will be I/6 of a circle, and that's how we calculate this angle. After we run the demo, let's crank this up to maybe 60 and try again and make more points, and actually, you know what will happen is the more points we make, the more our polygon is going to look just like a circle, and we'll demonstrate that as well. So after we finish iterating through that for loop, and because we're doing a list add each time, we effectively wind up producing this big long list of x and y values. I don't know if it's obvious to you or not by looking at this, but what's going to happen is the polygon points list is basically an x value followed by a y value followed by another x value followed by another y value. So in other words, every second value in the list is an x value or y value, and every other value is a x value. So in other words, they aren't paired together somehow. They're just one big long list containing x, y, x, y, x, y all the way through. Since we are going to be repainting this every time we size the window differently, it's going to be important that we always clear all the children off, which we do in this line, and then add the freshly determined new points for the based on the current window size as children to the group. So that's pretty much what the code does. Now let's have a look at the demo. So we're going to go ahead and run it now. And there you go, we have a polygon as promised. It is going to dynamically resize as we resize the window. And if I make the window really skinny, short but wide, you can see that it takes the smaller of the dimensions of the window to decide how big to make that polygon. And likewise, if I do the opposite, if I make it really skinny and tall, it again uses the smallest dimension to decide how big to make that thing. Now let's play with the code a little bit. Let's do a couple of things. Let's first of all switch from 6 points to 60 points and have a look to see how that looks. So let's keep this handy. We'll tuck it away off to the side here. And let's simply put a 60 here. Now that's not the only change we're going to have to make for this to work out, because we've also got a divide by 6 here that's going to have to become a divide by 60 instead. So with those changes, we should be able to see a 60-sided regular polygon. And there it is. Well, it already looks an awful lot like a circle, doesn't it? I don't know if I can make it big enough to show that it's got non-round sides. I guess not. So maybe we sort of did some overkill there. Let's prune that back to, let's say, perhaps 20. So we're going to change the divisor to 20 and the number of iterations to 20. We'll try again. There we go. So there's a 20-sided hexagon. That now completes chapter 14. At this point, we've seen how to make all kinds of neat-looking graphics. And although we had a button in one of our graphics, or more of them, we could click on it, but nothing interesting would happen. We weren't actually able to take any input from these GUI interfaces that we made. It's just the graphics only that we're producing at this point in chapter 14. Now we can prepare to get ready to look at chapter 15, where we'll look at event-driven programming, which will teach us additional tools that we need to know about so that we can actually make useful GUI interfaces, and we can collect input in terms of clicking on buttons and moving the mouse to certain places and typing text in and so on and so forth. And that's where things will get even more interesting yet.